Alright, in this video we're going to look at using transformations again, but we're going to use them to graph an exponential parent function. Okay, so you will need graph paper for this, so if you don't have it handy, go ahead and pause and go grab some. I've got mine set up here on the page. The example we're going to do is we're going to graph using transformations. Okay, so we'll need a parent function in the transformations. The function that I want you to graph is f of x equals 1/2 is our base to the power of negative x minus 3, and then out to the side minus 6. So we're subtracting 6 from this whole thing. Okay, so make sure you've written that in a way that you'll be able to read it later. Alright, so what we're going to start with is I want you to first identify the parent function. So I want you to write the equation of the parent, y equals something to the x power. Okay, so exponential parent functions are always just a number to the x power. And then once you've got that, I want you to create an xy table. And since it's a parent function, it should be really quick to generate the x's and the y's. Now, what most people forget with exponential parent functions is to look at the negative exponents. So certainly put in some negative x values here, 0, some positive x values. Okay, put in enough so that you could quickly graph the parent function. And then calculate the y values by plugging the x values that you got here, whatever these are, plug those into this formula, the parent formula, to get the y values. Okay, so pause the video while you set up your xy table, and then go ahead and graph what you have here. You can graph it roughly, it doesn't have to be terribly precise. Okay, you should have that graphed in your xy table done now. Make sure that at some point you put the asymptote into your xy table as well. And I'll give you a big hint here. The asymptote for any exponential parent function, which you should be able to tell from your graph and your xy table, is going to be y equals 0. So I like to put it in the y column of my xy table. And make sure you graph that asymptote on your parent function, because we have to track that through the transformations. Okay, now let's do the transformations. Let's talk about the x transformations first. The x transformations are the most difficult typically. So in an exponential parent function, x occurs in the exponent. So you go look in your exponent and you've got this negative x minus 3. So you're going to extract that to help you decide what your x transformations are. So you've got your negative x minus 3 extracted. And if that were in an equation that you were trying to solve for x, you have to ask yourself the steps. There's 2 steps here. What's the first step you would do in words? What's the first step you would do to get x by itself here? And you're going to write that out here, and that's going to be your first x transformation. Then your second x transformation would be the next step that it would take after you've done the first step to get x by itself. Write that here. So those are going to be your x transformations. Okay? Now, pause the video, get those set up. Now let's look at the y transformations. The y transformations happen outside of the parent. And make sure you understand that the 1/2 is part of your parent function. That's going to be down here. Let me actually highlight that in yellow. The 1/2 is going to be part of the parent function. See, that is not a transformation. So your y transformation is going to occur from this minus 6. And it's literally what you see is your y transformation. So there's only one. Maybe you still want to label it as your first y transformation. Go ahead and write out what that transformation is. And that's what you're going to do here. Pause the video. Make sure you've got everything set up to this point. Okay, now the goal is to take our parent, which we've got right here, and apply these transformations in the right order. It doesn't matter if you do your x transformations first or your y transformations. Just make sure that you do the first x transformation before you do the second. And what you're going to do is x transformations are going to apply to the x column. So do your first x transformation to the x column, and you're going to get a new x column and the same y column. Okay, even your asymptote is going to stay the same. Then do your second x transformation to the x column, but now it goes on your new xy table, and you're going to get another new x column, and your y transformations again have not changed. Then you're going to do your y transformation to the y column of the most recent table, and so your x column is the same, and your y's change. Potentially even the asymptote. Don't forget to list your asymptote in your y column. So go ahead and pause the video. See if you can figure out your three xy tables. If you'd like, you could throw up an intermediate graph, just a quick sketch of each of those xy tables on a graph to kind of see what's going on, and then come back. Okay, at this point you should have your final xy table here, and now we need to translate that to your final graph. So go ahead and draw a rather precise graph of this last xy table based on the parent and the transformations that you've done. And then when you come back, I will show you the correct answer. Okay, your final graph should look something like this. And I've listed some ordered pairs that are on the graph. You may have other ordered pairs, but your asymptote should be at y equals -6, this horizontal line that crosses the y-axis at -6. And the graph should get infinitely close to that asymptote going to the left, and it should grow exponentially as it moves to the right. So if you did not get that, backtrack, check your x and y transformations and your parent function, see if you can find a mistake. But this is the final answer that you should get.